taking more time, we will start with the discussion. So you have any doubts, please put it in the chat message. Maybe further, if you have any doubts, I'll answer to you at the end of the session also. Right? Okay. Now, let's come to the agenda for today's session. So what I'm planning to talk to you all is like about deep learning. That's first. Then I want to just show you some data sets. I want to show you some working models that we have made. This is for all you to say that yes, deep learning is possible for a problem which you want to venture. Right? That's the whole idea of the discussion today. So let's start with the session. Okay. So to summarize, it is like deep learning is a technique which is everybody is talking about today, and deep learning is the concept which people want to try for any real-time problem. But questions is like, okay, why deep learning? Where is deep learning used? Why not I use some other technique? That's the next question somebody would ask. Or sometimes when you go to the people and say that I'm doing deep learning, they would say, why are you doing deep learning? Okay, why not you do machine learning and so on? So let's get a clarity around, then we will come down to the working models. So before I start my session, my acknowledgement to my students who have been working with me or continuing to work, my bachelor's in engineering and master's in engineering in Amrita. And second is my PhD scholars. So I have 5 PhD scholars. 3 of them work on video analytics with deep learning. 2 of them are working on behavioral security with deep learning. Third is the industry connects, because we learn more from the industry people. So industry people always guide us in real-time problems, whatever we work. So thanks to my connects in Intel, HCL, because they have been guiding me in some problems that I've been working with jointly. Ma'am, is the presentation visible? Madam?
Yes, sir.
Okay, fine. This slide is just to get you a clarity on what deep learning is, how deep learning is better. To all of you, like if I ask you a keyword, why you need deep learning, anybody can say why you need deep learning? Or where you go for deep learning? Any answer? Participants, anybody can talk, no problem. Where will you go for deep learning? It's a big silence. Okay. If you all say that, no, I still have a doubt, where will I go for deep learning? One word that I will always say to anybody is uncertainty, right? Just look at the uncertainty of the data. If the data is very uncertain, you can go for deep learning, right? For example, the expression on your face 1 hour back and the expression on your face now and the expression on your face after 1 hour, nobody is uncertain, right? So if I ask you what will be the expression on your face after 1 hour, you would say that it is dependent on how I deliver my lecture. If you don't like my lecture, maybe your expression will change. Or otherwise, you would say that I'm okay. I'm anyway interested to listen to the session. My expression will still remain the same. So there are many factors to a data that is being dependent on previous data, right? So if there's an uncertainty in the data, please go for deep learning. So please spend time on analyzing the data in the beginning before you go to deep learning. For some people, they just go into deep learning and start trying data and later conclude that deep learning is not a good solution. Please don't do that. Please spend time on understanding data, then you come to deep learning approach. Now the slide on the left side would show you a diagram for a neural network. The concept here is like this. You have a set of inputs. The inputs is multiplied by the weights. So the summed up product of the inputs and weights, you will get a value called as X. X will be checked against the threshold. So the threshold value is T. Based on it, it will associate it to a respective class. This is what a neural network does. Now let's see a quick summary on the right side about what a deep learning does. Deep learning says you give me a set of inputs. The inputs are given to neurons, as you see in neural network. But here you will have hidden layers, but the hidden layers can be more than one, right? Now, if the hidden layers can be more than one, you can give some new names for the layers. For example, if somebody comes into CNN, they will say that there's something called as a convolution layer, there's something called as a pooling layer. If you come to some other architectures, they will say that I have something called as a block layer. So each architecture in deep learning will give you special names for the hidden layers, right? This is first difference you should know. A neural network has got hidden layers, but hidden layers will have new names when you're coming to the case of deep learning. Now, what's the purpose of hidden layer? Hidden layer is basically allowing you to learn some knowledge. For example, if you ask your brain how many hidden layers are there, you would say, I don't know. Can you find a person whom you have met after 10 years from now? Yes, it is possible. Can you recall of a person with whom you have studied in the LKG? It may be possible, right? So every hidden layer in your brain is having a capacity to learn, and it has some representation. So because of which you give an input data, automatically your brain is able to say, yes, this is a person I met 10 years back. This is a person with whom I have studied 10 years back in my school, right? The same way here, your deep learning says give as much hidden layers as you want and define your functions for the hidden layers such a way your classification is successful. So the output of neural network will give you a classification. That means it will give you a class to which the data belongs. Same thing, a deep learning also will give you an output saying to which class it belongs. So neural networks is used for classification. Deep learning is also used for classification. Now the next difference would be is like the type of activation function. A neural network generally uses linear and non-linear activation functions, but deep learning uses non-linear activation functions, right? Then the common activation function in deep learning is ReLU. Last important difference is the forward propagation and the backward propagation. If you see a neural network diagram on the left side, in the forward propagation process, what happens is it finds the data to which it belongs, that is X, and checks with the threshold and says if this is a class it belongs, class can be 0 or 1. Deep learning also does the same. But deep learning does slightly interesting. What does it do is, in the back propagation it differs. In the back propagation, your neural network, what it will do is, it will use all the weights as you see in the diagram, right? And again, it will go forward and calculate the value of X. But deep learning is not like that. In the back propagation, it will use only the weights that has participated to the learning. It means all the weights that has been available in the deep learning model need not be used in the back propagation process, right? This is how a deep learning model differs from neural network. Okay, so in summary, deep learning gives new names for hidden layers like convolution layer, pooling layer. Second one, when you come to the case of deep learning, in the back propagation, only the weights that has participated to the learning is used. Third, deep learning generally uses non-linear activation functions. Now this slide is just to summarize about the things that you generally come across. And before we step into this, we can see some data that might help us to understand what is data and how data is very important for our analysis. Okay, let's see some small data here. So let's take, we open an Excel sheet. I'm just opening one Excel sheet. Let's put some data, right, for our understanding. Okay. So I just opened an Excel sheet. So I just put some data. Now, what data you want? You would say that yes, data is available, some features. Right? Okay. So the features are meaningful to us. For example, somebody says, I just want to classify today's sky. Is it cloudy or not cloudy? Right? You have 4 features here. Let's take, you want to make it meaningful. I'm just giving some name for the features, right? So name for the features, this first feature would be like, what is the temperature? Okay. Then somebody would ask, okay, what is the moisture that you have in the air? Okay, somebody would say, is there any rain? There's some rain level today, right? Okay, then finally somebody would start asking, how much is the pollution level? Right. So a data is understood as features, right? But the features have meaningful names. So for example, if I want to talk about the cloud, I can actually say it is dependent on cloud level, right? Okay. It is dependent on temperature, moisture, rain level, and next is pollution level, right? Now, if I start giving some data, let's take 12. Moisture is 34, right? Rain level is 34. Pollution level is 12. Okay, right? So like this, if I give one more data, 12, 34, 32, 23. Now somebody would ask, okay, all this is fine, but why don't you talk about what is a cloud level, right? That becomes your class. So now the understanding is all these are called as features, F1 to F4. All this F1 to F4 is called as label. What is the name for the label? Temperature, moisture, rain level, pollution level, right? So given some features like this, what we want to do is we want to classify the data to a respective class. So somebody would come from the other side and say, what is your opinion about cloud? Somebody would say, it looks cloudy, right? Somebody would say, it is not cloudy. That's all. I want to just classify like this. So you would start getting class variables saying cloudy, or somebody would say it is not cloudy, right? So now when you look at this, it becomes a single class problem. That means you know whether it is cloudy, that's all. But you cannot classify how much it is cloudy, right? So this is an example of a single class problem. Now somebody says, no, why don't you take it as a two-class problem, right? So if you talk about a two-class problem, then the answer would be very different. They would say that, okay, it is cloudy, but it is medium cloudy, right? And somebody would say it is less cloudy. So I have some inference about what is medium cloudy level, and I have some inference about less cloudy level, right? Anything outside this, then people say that it is not cloudy, right? So this is an example of two-class problem, right? Something people will go around and say, no, it looks very different. Why do you want to give like medium cloudy, less cloudy like that? Just give it as some sort of variables with equivalent label values, right? So medium cloudy means 0, less cloudy means it's 1, right? Okay, medium cloudy is 0, less cloudy means 1, right? Then you say, we put something as average, so it is 2. So now your class labels are 0, 1, and next is 2. Now it becomes a multi-class problem. So your data as such can start from single class, can become two class, can become multi-class, right? So if it is a multi-class problem, automatically your class variable values also will change like that. This is 0, this is 1. Now I give one data, let's take 23, 22, 22, 34, right? Now comes the question, what is this class label, right? Now, to answer to this class label value, I already have some inference. What is this inference? I have some inference about 0 and 1. With that, I might try to find out what class label it belongs. This is either 0 or either 1. Okay. So here, what comes in is the concept of learning. So people call learning in 3 keywords. One is called as supervised learning. Second is unsupervised learning. And third one is bagging or boosting. What is supervised learning is, if you want to classify a data, now you can see here, I want to classify this data. That means I want to predict the class label. I already have some ground truth, right? There I need to go for something called as supervised learning, right? But other way around, I have data like this, but I don't have the class label at all. First, I want to find the class label for all this data. Please see here, I want to find the class label for all this data, right? There, what you need to do is you have to go for an unsupervised learning. Example of unsupervised learning is K-means, right? Example of a supervised learning is KNN. If the data is real time, then what you will do is you will just use real time K-means for unsupervised learning, and you can still use KNN under the supervised learning mode. So please get this always. Given some data, go and check the class label. If there's no class label value, you have to find the class label by using a K-means algorithm. It's a real-time data, go for real-time K-means. And once you are able to classify the data, now the understanding to you all is, I tried with K-means, I got the class labels as 0 and 1. Now my question here is, what is the class label? Since I have a training data like this, now I can use a KNN and I can say which class it belongs. The class can be either 1 or class can be either 0. Okay, right? This is keywords behind learning. First is features, then next is classification, and third is single class, two class, multi-class. Last keyword is learning. Learning means supervised learning, unsupervised learning. Unsupervised learning example is K-means. Supervised learning example is K nearest neighbor. Okay. Now, the next keyword somebody would ask is training data and test data. This is training data, right? Because when I want to find the class value, please see here, when I want to find the class value for this is your test data, and already generated class label data is a training data. Okay, right? So you will have training data and test data for the problems. Sometimes you don't have any training data, like what I was trying to discuss with you. There is no training data at all. Then you have to run a k-means, find a class label for this. Now this becomes your training data. So when you give a test data, you'll be able to classify and say which class it belongs. Either it is 1 or 0. Okay, right? Now, the next keyword for all of your information is feature vector. What is feature vector? Is group of features together is called as feature vector. Are you getting it right? So I have 4 features: F1, F2, F3, F4. So F1, F2, F3, F4 is called as feature vector, right? The next one is dimension of a feature vector. What is dimension? Number of features minus 1. If there are 4 features, 4 minus 1. I can have 3 dimensions to the data, right? This is about dimension for a feature vector. Last one is dimensionality reduction, right? What is dimensionality reduction is, I have 4 features, right? Maybe I will try to form one feature here. Just watch here. I'm calling this as F21, or let me call it as feature itself, right? I'm finding a new feature and I'm calling that feature to be temperature level. I'm calling that feature to be temperature level. Fine. So if you're not getting something, please type in the chat message. I'm calling it as temperature level. Now this temperature level, I would say it is max of, fine, this 2 features. Okay. So max of temperature comma moisture will give me something called as max of temperature comma moisture will give me something called as feature, which is temperature level. Now I got temperature level. If the problem domain says do not use temperature and moisture, just give me a feature called as temperature level. I have created a feature called as temperature level. So what I can do right now, I can actually go here and I can hide this. That means I don't need this features at all. Now this becomes one feature for me. So I will call here as F1. See the change in the data. Originally you had 5 features. Since the problem said you can have temperature level as a new feature dependent on temperature and moisture, I have created a new feature, right? Now, if you look at the feature vector, it is no more 5, it is 3. So what I have achieved? I have achieved dimensionality reduction. So what is dimensionality reduction? Is scaling down the number of features. Is called as dimensionality reduction, right? Okay. Now, this can happen either by like what we did, no? We did max. Somebody would go for min, right? Somebody would go for a standard deviation also. All this becomes examples of statistics features. That is, you have to know what is statistical features. To know that, usually I suggest this website. If you can parallelly do, it will be helpful. Please go to your internet. In the browser, you will find something called as xuru.org. Right? xuru.org. So in this, you will find a link called as statistical tools. Now come to the right side, you will find descriptive statistics, right? You can take some data what you have just for your inference. You can take some data what you have and you can paste it, or I will try typing the values. Right? And just type the values. This is one feature which I want to consider for statistical measures, right? So I'm giving calculate. It will generate the statistical features for this given data. At least people know what is mean, median, standard deviation, variance, kurtosis, and so on, right? This is very important for anybody who want to be good in deep learning or machine learning, right? You should know statistics. Reason is, as I told you, you would be interested to create statistical features. Like I created one feature like temperature level. But in your problem, you might create a new feature called as area. You might have a feature with respect to standard deviation. You might have a feature with respect to variance. There, you need to talk about statistical features. So there, it will be really helpful. So suggestion to the people, please have a reference of this site. right? This site will be helpful for you to know about statistics. Okay. Then next is a concept which I want you to have a look at is distributions. Whenever you are given a data, what you want to do is you want to do data pre-processing. If you want to do data pre-processing, first you should understand how the data is. If you believe that all times your data will fall into some distribution, then you can go and check. For example, this is my data. I can go and check what type of distribution it falls. If the distribution is to be normal, I can go and check what type of confidence it's supposed to have, right? So let's take, for example, the confidence value is 0.08. Just take it for your reference, right? Confidence value is 0.08. So this is a perfect data. So my client has said, sir, in your data, whatever data I given is correct data. So this is a correct data from the client, right? So confidence value for it is 0.08. Now, when I get a new data, right? When I get a new data, let's take my new data is something like this. Just see here. I'm just making a small change. I'm making a small change. Here, what I had as 23, I change it as 123, right? So if I go down and click calculate, right? And just scroll down and see what is happening to the distribution part. The distribution is normal, but see the change, right? Distribution value is showing a confidence of higher value. But what was the original value I got is very less. That is correct data. But the new data that I've got is showing a higher confidence value, but still it's normal distribution. So there comes a question to check. There is something wrong with the data that I've got. So what can be the wrong part in the data? One, it could be a case where there is a noise in the data, right? For example, this is supposed to be 34, but what I'm getting instead of 34 is I got it as 134, right? So that's a noise you can see here, right? So because of this, I need to talk about more about pre-processing. So what would be pre-processing would be is, there are three ways of looking at pre-processing. One is looking at noise. This is 134 is a noise. So I'll have to go and correct this noise, right? One, I can manually go and correct the noise, finding out, okay, 134 is not allowed. Or I'll have to write some algorithms for handling noise. This is first information to all of you. Second thing is missing values. See, I have data here, right? But this data is supposed to be 23, right? But there is an empty value in this data. So because of this, I got a normal distribution with a higher confidence or a lower confidence, which is violating the original understanding of the data. There, it is also noise. So you'll have to go and see how to fill the missing values. There, what people suggest is, if this data has got changed, originally it is 134, now it is 34. What people might say is, you just find the average of it, right? So this is 34. The other one you take here, right? And divide it by 2. You'll be able to generate a value. This is an example of finding the missing values. So pre-processing is generally about two things. One is finding missing values. Second is about noise, right? The third one in pre-processing would be something like this. Let's take, I have a column, and I assume the column here is going to be very different. I'm giving a column here saying color, right? I want to look at the color of the sky and say whether it is cloudy or not. So let's take the color is blue. Somebody says white, okay? Somebody says light blue. I cannot use like this to work with algorithms. So I'll have to convert this to a numerical value. So how will I want my numerical value? I want my numerical value to be something like numbers, like this, 0, 1, like this. Here, what we do is we go to an approach called as one-hot encoding, right? What we do here is we go through an approach called as one-hot encoding. One-hot encoding is an existing approach. You are not doing anything here. If you go to the internet and type one-hot encoding, right, you will actually get what is one-hot encoding, and you will find a library called as one-hot encoder in Python. I think people can see now. You'll find a library called as one-hot encoder in Python. So you can just call the function. Once you call the function, what it does is it will convert the original text, like what we had, no, categorical values, into numerical values using one-hot encoding. This is also pre-processing. Okay, so in pre-processing, you will have to look for noise. You will have to look for missing values. You will have to look for categorical conversion. That means any categorical value has to be converted to a numerical value. Common procedures, one not encoder, right? Any doubts for anybody till here? If there's any doubt, you can put it in the chat message. I'll just wait a minute and see. If there's no doubt, you can say no doubt so that I can go to the next. Participants? No doubts means please say no doubt so that I can move to the next slide. No. Okay, no means no doubts. Okay, fine. Thank you. Right. Now, let's come to the next part. Now, what we know about is the importance of having statistical features, right? But the other thing that you can see in this link is this is a very good site. In fact, I'm referring for last more than 10 years to teach, understand, or know quickly something is existing from a conceptual part. If you go to statistical tools, you'll find something called as probability distributions. Here you'll find different probability distributions. Most of the things we would have learned, normal, binomial, Poisson, chi-square, right? Many algorithms in machine learning are around the distributions. So you have to know the distributions. Please learn distributions under this list. At least you should know something with respect to normal, binomial, and chi-square. All these three is generally used when it comes to programs. So please learn through the distributions. That's my next suggestion to all of you. Right. The next one is, given any problem, I want to come into deep learning. What all happens in deep learning? Okay, that's the next question somebody would ask. Before we go into that, let's move on to the slide. Now you know about class label, right? You know about data as features, feature vector. You know what is prediction? Prediction is what we are doing under the testing process. Right. So a data given, you want to classify the data into different classes. Fine. Now, how many classes? It can be single, binary, or it can be multi-class. You want to formulate it as a regression problem. Now, the question comes up, why regression? See, some data by nature, it will be either discrete or continuous. Please make a note. Your data will be either discrete or continuous. Based on the characteristic of the data, whether it is discrete or continuous, you can formulate it as a regression problem, or you can formulate it as a technique which is a classification problem. This is very important as a first step. So look at your data and see whether it is discrete or continuous. Based on it, either go to regression or you can go to classification problem. If it is not regression, you will come into classification where you will use a clustering, which is a k-means clustering, and you will classify it to the respective clusters, right? Now, what is data? Where do I find my data? That's next question from anybody. There are many sources on the internet for data part. I'll show you some data sources. First one is Caltech dataset. You go to the internet, you'll find something called as Caltech dataset. It's a very good dataset. Reason is like you'll get 360-degree images of data, right? Now you can actually use this data set and you can see what results you are getting is correct against the existing result or not. What is this 360 degrees? For every object, they have taken 1 degree difference and they have captured an image. So you will get 360 images for every object. So first source of data you can take is Caltech. Second source of data, which I generally suggest, is outlier detection data set. Advantage of this outlier detection data set is you will have different type of data sets. For example, if you want data with respect to attacks, you hear of attacks, no, in buildings, hotels, restaurant, and so on. You'll get it. You want to work on time series, you'll get data sets here. Right? This is second source. Third one, which I generally suggest, is Kaggle data set. Because Kaggle has got every data almost we work. Even COVID data set is also live on Kaggle for you to work. Right? So these are primarily 3 data sets which I suggest. Now, among all this, the next question somebody would ask is, okay, which one can I use? It's up to you. If your data can come from Caltech, please take it, or you take it from Stony Brook, or you take it from Kaggle, right? or you can take any other data sets on the internet. For example, if I'm interested to work on something on emotion of faces, right? So I say facial expression data set. I have something from Japanese. So you get Japanese female facial expression data set, right? So this data set is there, and if you see the review for the data set, this is from 1990s. It is available. If you want, you can take this data set also. So based on your problem, you might land in one data set which you have to start working. Okay, this is next information to you all. Where can I go, or how can I start my data sets? If your problem does not have a data set at all, then in that case you have to start doing a crowdsourcing. Crowdsourcing means you have to use your camera and you have to capture data set and you have to start building your data set. Now, when you start building your data set, then the next question somebody would ask is, okay, how can I talk about my data set? Okay, I have a data set or I want to build a data set. Then how can I talk about my data set? There are generally some conventions in describing data set for information. So conventions are more around the characteristics of the data set. Let's take, you talk about your first one type of data, right? Somebody would ask you, okay, are you working on image or are you working on video, right? If you say I'm working on an image or a video, then next question would be, it's like, okay, number of images, right? Or number of video. This is next question somebody would ask you for your problem. Okay, so you would say, I'm using 60 images, or you would say, I'm using 20 videos, right? If you talk about video, they will ask you, what about your frames? So can you talk about your frame resolution? What is your frame resolution that you have, right? Then they will ask you, okay, what is your frame rate? Okay, then somebody would ask you, can you give your camera details? With what camera did you capture your data, right? Then last, somebody would ask you, is like, okay, you built a model which is using machine learning or deep learning. Then what did you do in your training phase, right? So what did you do in your testing phase? Then their answer should be, is like, I used 70% of my original data, right? So let's take 20 videos you're going to work, right? 70% you are using for training. So that means 14 videos you are using for training, right? Testing will use generally 6. That means this is 70%, right, of your original data, and this is generally 30%. This is usually from research papers or from general terminology, right? Then somebody would ask you, okay, you did a training and testing. Can you say how many positive samples was there, right? Fine. And how many negative samples was there in your training? Now the question would be, is like, okay, what is positive and what is negative? Somebody says, I have a fever, then you would always go and check your blood test. Then now we have got a new class of fever called as COVID, right? So your blood sample is tested against COVID also, just for an example. So whoever has got COVID, their blood samples knowledge is created, and that is called as positive samples, right? Who do not have COVID, that is also taken. Please try to understand, right? Now, usually people have a question like, how many should I have? You can always increase positive samples. You can increase negative samples also. But please always understand, you are interested in saying to somebody that you don't have a COVID, rather than having a confusion that you have a COVID, I have a doubt whether you have a COVID, right? So people generally talk about increasing the number of negative samples. In all your problems, make sure that you have more number of negative samples compared to your positive samples in your data, right? Once this is done, then the last question somebody would ask you is like, okay, what is your performance parameters? So there you'll say, I'm using precision, or I'm using recall, like this. Or somebody would say, I'm using accuracy, right? Most commonly, people generally uses confusion matrix, right? This all this 4 comes into something called as performance parameters to your data, right? This is how you should start looking at your data. This is for image or video, right? If it is to be the case of talking about an Excel sheet data, right? So let's take through that also, just a small understanding. This, okay. So if it is an Excel sheet data, right, then you'll say my type of data that I'm looking for or I'm having is CSV format. Then you'll say, you'll not talk about number of images or video. Here you'll say I have totally how many number of features, right? Then you'll start saying like, okay, do you have any class label, right? Fine. Then you will start saying type of data, because this is very important. I told you already. Based on this, you can go for regression or classification problem. So you will say my type of data is discrete or continuous, right? So rest of the things are same. Training, I'm using 14 records. Testing, I'm using 6 records. Total number of records that I have here is 20 records. Right? So positive samples, negative samples need to be high. I use the same performance metrics like precision, recall, accuracy, confusion matrix. This is how you should talk about your data description when you're coming to your deep learning, right? But please, to all of you, please spend some time on data understanding, on building the data. Don't be in a hurry to just take the algorithm and run. It will become a mistake at the end of the analysis also, right? This is just for information. Then next question somebody would ask you is, okay, all this is fine. What is your programming environment that you're going to use? So when it comes to programming environment, answers are many people will give different answers. Somebody would say, I feel I'm very good in MATLAB, right? I will be interested to work with MATLAB. So that's also a very good answer, because MATLAB has got a good toolkit for you to work, right? The other answer would be like, most of my architectures are built in Python nowadays, right? So I'll use Python. Then people say, what is your deep learning framework you're using? You'll say, I'm using Keras, right, as your front end. Then Keras is your front end for all your information, right? Then people ask you, okay, if you're done with Keras, what is your backend? So you'd say, I'm using a backend. Backend can be Piano or TensorFlow, right? There are other third-party libraries in the internet, like PyTorch is there, right? Many more, right? You can use as per your choice. Now IBM has also got its own tool for deep learning, right? But from an open source community, this is good. From an academic community, this is good, right? Because you need not pay anything, and you can code, you can modify, and you have the flexibility to change the architecture as you want, right? This is from the programming side. Now the next question comes from anybody would be, I also want to have my environment, right? Okay. So answer would be like, just go to internet and download Anaconda. Right? Anaconda is a framework which is there for deep learning. So you can go to Anaconda and you can download the framework. It's very easy. If you go to internet in your browser, if you go and type Anaconda, right, framework, you'll get Anaconda software. You can just go and you can download it. Once you have downloaded, Anaconda will come up in your system. You will have an Anaconda prompt, right? If you type Anaconda prompt, you'll get your prompt window coming up. See, Anaconda gives you 2 editors. One editor is Spider, right? And the other editor which you will have from Anaconda is Jupyter, okay? The difference is, as much I know with my limited understanding, Spider as such, you can write a code and you can run it in the framework and you can see. Jupyter understands everything from a notebook perspective, Python notebook, right? Now, you will get your Anaconda prompt like this. You have now Anaconda, Jupyter, and you have Spider. Now, the next question is like, you want to install Keras and TensorFlow. So command is pip install Keras. So it'll go to the internet, it will try installing, it will complete it. In my system, since I have already installed, it will say that requirement is satisfied and you need not install. I think you can see here, right? Requirement is already satisfied. The next is, now Keras is there. Now I need TensorFlow, same procedure, pip install TensorFlow. Right? So when I give like this, pip install TensorFlow, then again it will connect to the internet. It will try installing TensorFlow. it will say that the requirement is already satisfied because I have completed the installation, right? Now, once this is done, then next question people will ask is like, you need some frameworks for image processing. So I'm trying to use OpenCV. OpenCV is Open Computer Vision Library. So built on Python. So pip install OpenCV-Python. This will also go to the internet and try installing. Since I've installed it already, it will say requirement is already satisfied. This OpenCV, you need it only when you're going and working with images or video. Otherwise, it's not required. Okay, that's all. Now this finishes the environment. Now the last step you are supposed to do is you are supposed to create a text file, and that text file will have a name called as Keras. Okay. So you are supposed to make a text file like this, call it as keras.json. I'll show you here. So keras.json. So your extension of the file would be like this, keras.json. Don't ask me why. It is all procedure from the environment. Right? So now, why are we doing this is, TensorFlow is separate, Keras is separate. You want to connect TensorFlow with Keras. That means Keras will become a front end, TensorFlow will become a back end. So you are supposed to create a new text file like this, right? And in the text file, you will place a code like this. This is there in the internet. There you are supposed to make backend. There you can type it as TensorFlow, right? Once you have done it, you are supposed to save where Keras is installed. In my system, under Sendil directory, there's a Keras folder. Within that, I can go and save. Suppose we are not going for TensorFlow, rather than we have installed Theano, right? Pip install Theano. Here you are supposed to go here and change it as Theano. Once you save this once for all, right, you have to restart your system again so that the settings will take effect, right? This is how you can set up your environment for doing a deep learning code. This is for people who have facilities and they can do it properly. But somebody says, I have a large data, but my data cannot be running in my computer. I need a remote computer or a remote server to work. Their answer is like this. You can actually go to the internet, and there, if you go and type Google Colab, you'll get your Google Colab. There you can push your code and you can run your code. This is also a good solution for running. Here, you are not using your system's capability. You are relying on Google Colab, and there you're going and running your code, and you're able to see the output. Okay, right? This is about the development environment for doing deep learning. Any doubts with anybody? If there's no doubts, please say no doubts so that I can go next. Okay, no doubts, fine. See, I'm talking to you or presenting in a way in which I learned deep learning. So some things may be very basic, but please bear with me. Now, you know about data sets, you know about the development environment, right? Now, once you're done with it, you have basic understanding of what a deep learning does. Now, next what we want to talk about is feature engineering. Most of the people ask this question, feature engineering. Deep learning was built for images. So if you give an image data, it will understand pixels. Pixels can be connected as edges. Edges can be combined as regions. With that, it will be able to classify to a particular image. Here I give a cat image, it will fall in and say it is a cat image, right? And then it will classify the data. Now, what is feature engineering is, at every layer, it is learning the features like edges, regions, and so on. This is what is called as feature engineering. This deep learning model generally understands pixels together as features and learns. But in case you want to form new features, somebody says, I give a picture, based on the area of the picture, that is the size of the picture, I can say some information about this picture. Then I want to have a new feature called as size. For that, I can talk about a diameter also as a parameter, right? So there you have to start writing your code. But what feature engineering generally means is you give image, it understands as pixels together as regions and learns information about the image. Now all these keywords are familiar to you now. Features, feature vector, dimensional detection, class label, and next is classification. Now what deep learning has as keywords is, first keyword it gives you is something called as filter, right? So filter is nothing but it's referred to as neurons. So what will be there in the filter is weights. So we have already talked to you about weights. So second information is about depth. Depth is nothing but the same as the depth of the input. Now depth is more connected to filter. Now if you talk about an input image which is a color image, assume the size of the image to be 32 cross 32. So it is going to be an RGB, so red, green and blue. So 32 cross 3. Filter size is 5 cross 5. So 5 cross 5 into 3. When you apply filter on the input, what you get as result is 28 cross 28. Reason is a deep learning model can take data only as a square matrix. So output will be 28 cross 28 cross 1. This is something called as an activation map, right? Next, two operations are generally there. One is called as stride and second is called as padding. What is padding is, if you take a data, let's take a data here for our understanding. If you talk about this data, if you want to feed this to the deep learning, you cannot feed it. The reason is number of features is 4, right? But the data is you have is 3. So it is 3 cross 4. So what you are supposed to do is you are supposed to add one more row, right? And you are supposed to fill the rows with zeros, right? Now what you will feed to the deep learning architecture is like this. Now it becomes a 4 cross 4, which is fed to the deep learning architecture, after which you can do the classification and prediction. This is called as padding. What is padding here is, I will fill this last row with zeros, right? What is stride? Stride as such will say, how are you going to apply the filter? So if I take a filter and apply it on the input image, this is my input data. I would take the filter and apply it on the first 2 cross 2. Or assume that my problem says, don't worry about the corners of the image, worry about the middle part. This is my middle, as I'm highlighting in the discussion. So I will take the filter and apply here alone, right? This is called a stride. So stride will say, how will I apply my filter on the input data, right? So don't forget these two keywords. One is stride and next is going to be padding. So there are a lot of architectures built. You have CNN based architectures, many is there. You have hexagonal CNN is there. You have RNN is there. And you have special architectures like YOLO, GoogleNet, and so on. But my request is please spend some time to learn CNN and then come to some other architectures. Okay. Now, a deep learning model will say at every stage it is understanding data as neurons, right? So it will actually find sum the product of weight into input data, and it will find the difference with B. B is nothing but your bias. What you get every time is Y. So you will get a loss value. What is this loss value is? It is like this. If I give a cat image, it is classifying it as cat, but there is already a training data with which I can say how much this value differs from that value, right? So that is what is called as loss. So loss is the difference between expected and actual. So deep, if the loss is not convincing, that means it is not good. It goes to the back propagation, again trains a model, and again finds a new class it belongs. It keeps continuing until the losses become minimal. Okay, this is what a deep learning does. So at every time there's a forward pass, there's a backward pass. What happens as a parameter update is the weights alone will keep on changing, right? Now, a performance of every model is important. If you're taking machine learning or deep learning, people ask you, what is the performance you achieve? These are all the parameters. I think people know from discussion now there is something called as positive samples, which is P. There's something called as negative samples, what is N? So a positive sample getting classified as a positive sample is true positive. A positive sample classified as a negative sample is true negative, right? And complement to this will be false positives and false negatives, right? Okay. Now, a false positive means you give a false, you give a negative sample, it gets classified properly as a negative sample. Then that case, you are coming up with something called as true negative, right? The complement to the true negative will be false negatives. So TP is true positive, TN is false true negative, FP is false positive, and next is FN, false negative. So what is false positive? It is like this. You give a negative sample and it gets classified as a positive sample, right? It's very dangerous. So we want to minimize the number of false positives in any problem. So please make a note. The purpose of all this modeling technique is to minimize the number of false positives. And one mistake which I have been also doing in the initial stages, I used to use all the performance parameters. But now by practice, I have learned that for a problem, all parameters are not required. For example, if I want to detect a phase, just a detection of phase, right? Then I will use precision recall. If I want to detect whether it is Sendil Kumar phase, then I will go for accuracy. Please understand the difference. So all problems need not use all performance parameters. This is for machine learning. Now the same if you come to the case of deep learning, it's very different. What a deep learning does is, deep learning says, you give me some data, but I can give you an analysis which is based on a probabilistic side. So what is probabilistic side? Just look at the case here. See, I've got 7 predictions in the sense I given test data as 7. That means the number of records in the test data is 7. For the first record, it is classifying as 1, second is 0, third is 0, fourth is 1, fifth is 1, sixth is 1, and seventh is 0, right? That is a metric called as average precision. This we are talking about in terms of deep learning. So what is precision at 1? 1 means the first. You take the first one alone. This is 1 by 1, right? Reason is number of ones that has occurred is only 1. So out of 1 occurrences, 1 is occurred. So it is 1 by 1. See the precision at 2. Precision at 2, if you see here, you got 0, right? Then third, if you come for precision at 3, it is again 0. When you come to the case at precision at 4, see at 4 here, number of ones is 2, number of zeros is 2, right? So totally it will be 2 by 4, right? So average precision means sum of current instances divided by total number of instances, right? So if you can see here, if you take the first 4 together, sum of it will be 2. Total number of instances 4. So 2 by 4 will be the average precision at the 4th test data, right? So like this, deep learning gives you special parameters for performance. Now, deep learning usually talk about all the stages. People say that you have to do data collection, you have to do data pre-processing, then you have to assign some parameters, you have to tune the parameters, you have to do the stopping criteria validation. Last is visualization, right? Let's see all of this in a small GUI, which is there on the internet. This GUI is just for you to learn deep learning. Okay, it is not for you to upload any cloud or something. This is called as playground.tensorflow.org, right? Playground.tensorflow.org. Now in this, if you come, first one will be epoch, right? Epoch means how many times you want to run the model. If you scroll down, you will find something called as data, right? Now, this is a point which I want everybody to understand why people are talking about deep learning, why there is uncertainty in the data, right? See, what is certainty in the data would be like if I have an XY axis, right? I have points. I can classify the data very nicely by using a line equation. I'll show you here. You see here, no? This is a set of data points. I just draw a line. I have classified. So points below the line is positive, points above the line is negative, right? But this is not possible for all data. That is why we say it is uncertain, uncertain, uncertain. Now, when you have data like this, fine. So you want to solve it with regression problem. So you can always go to regression. Let's take the same website, xuru.org. So here you'll find regression tools. Right side you'll find something called as linear regression. Linear regression. If you come down to the text box, you can type the columns. Linear regression expects 2 column values. So you get 2 column values provided. Now you click calculate, you get a line equation. Y equal to mx plus c. I think every one of us know what is a line equation for understanding. So this is my line equation that I'm seeing. So points above the line, points below the line. How do I say points are closer to the line or far away from the line? You need something called as error. That error would come up in the next part. If you come down here, you will find something called as error. Is it okay? So your line equation is provided. There is an error component to it. Based on the error, you can say how much it is closer to the line or how much it is far away from the line. If you can look at here, somebody would say 7.76 is higher, whereas 3.8 is lower, right? So some points are closer to the line or some points are far away from the line. Now look at this line equation, right? Look at this data, right? Now look at the maximum error. Maximum error is 7.76. You see some 6.76. Now I'm going and making some small changes in the data. Right? I'm going and making some small changes in the data. Now, originally it was 23. I'm making it as 13. Now I go and click calculate. Right? If I go and click calculate and come down, see the difference. Where you saw 7 is no more 7. It is 1.09. You never saw something like 9.36. Now you're getting 9.36. So the hypothesis equation also will change. The line equation also will change. This line equation is what is called as hypothesis. Okay, right? Now, this hypothesis equation, how will you write here in regression? Y equal to mx plus c plus error. What is error here? Error is what you see here in the values. Right? So, request everybody to learn linear regression. Whenever you learn the regression, please learn the parameters also, like correlation coefficient, residual sum of squares, coefficient of determination. All this are theory with respect to the regression, right? If you want to compare one regression with other regression, you need to go and check what is the value you're getting for R, right? You take linear and let's take you're taking logarithmic regression. You would be interested to go and see what is R. Based on that, you can say which regression technique is perfect. Okay, so this is a suggestion to all the people to have a look at regression concept, because most of the problems are solvable as a regression problem, right? So now what I want you to take through in discussion is with respect to this tool, playground.tensorflow. Now data is like this. I cannot draw a line, right? So there what I do is, okay, let me go for kernel. Somebody will in the audience would say, we'll go for kernels, right? Kernel linear is there, non-linear kernel is there. If you go to support vector machine, you have linear kernels and non-linear kernels. But again, can you formulate a kernel equation for a data like this? Or can you formulate one like for this? It's very hard, right? Their deep learning is very strong. This is why we say uncertainty of the data. Data is of 2 class, if you can see here, but I cannot use a kernel to formulate it. So their deep learning does it very nicely. So you can select whichever data you want, right? Here again, you can classify, but there will be 2 lines intersecting, right? Here you can see that you need to form a hypothesis, but in the reverse direction. So let us take this one. The next one people ask is, what is the training to testing? As I told you, let's take, we say 60-40, for example. Then next is, what is the amount of noise you'll have in your data? You can say, what is the amount of noise? More the noise, you can see the distribution changes. Can you see on the right side? Okay, you just move this forward, backward, you can see that noise changes. Next is the batch size, right? You can say what is the size of the batch for training your data. Then next, if you come down, it will ask you few inputs with respect to parameters and hyperparameters. What is parameters is number of features, for example. This number of features will correspond to the number of neurons. If somebody asks me like, okay, can you say me how many feature will I have for a data like this? Let's see here, right? If you see here, there are 4 features, right? So if you look at data, then what happens is, how many records are there? You have 3, 6, right? 6 by 4. But you cannot have 6 by 4. If I assume sample ID is not there, right? I have only these 4 features. Then what I'm supposed to do is I'm just supposed to have 2 more columns, right? And that 2 more columns will have padding. I think people can understand. If I go for 4 and I go for another increase of like this, what happens here is now I got 8 by 4. So what I can do is I can take first 4 by 4, give it in batch 1. It's a square matrix, please understand, right? I can take the next 4 by 4 and I can give it in batch 2, right? Like this, I can say how many batches I want to give it for training the data, right? So this is the keyword behind batch. And parameters are parameters which are related to the number of neurons. So if somebody asks, okay, what may be my number of neurons in the data, right? At every batch, what are you doing? You are giving 4 by 4, right? So the number of neurons is 16 neurons because you need 16 neurons to hold data of 16 values, right? Right. The next is people will come up and start asking, okay, what are your hyperparameters? Hyperparameters are one which will change in the problem, right? For example, if you ask yourself what can be the hyperparameter, learning rate is a hyperparameter which can change. Activation function is there. You can change the type of activation function. It can be ReLU or other activation. Standard is ReLU. You can say what type of regularization you can use. This is more connected to the type of optimizer that you use. There are many optimizers in deep learning. One common is an Adam optimizer. You can specify what regularization you want. You can say what regularization rate you want, right? You can go and see whether it's a classification or regression. It's a classification, fine. Now the next question would be is like, okay, come to the layers. How many layers you want? You can increase the layers in deep learning. That's why it's called as deep learning. At every layer, you can have different number of neurons. Please say the things. At every layer, I can have different number of neurons, right? And this, as such, will have a dependency with respect to the weights also. When the number of neurons changes, the weights also vary, right? Now, if you look into your data, just watch this. This is your data. This is features. This is all my parameters. Now, epochs. I start creating my model. I click. What happens is it starts calculating loss. What is loss? Difference between expected and actual. It will keep going, right? It will keep on going until my loss becomes minimal, right? Okay, this is how a deep learning model works. A deep learning model needs to have a set of parameters, that is number of neurons, features, and so on. It has to say what are all the hyperparameters, and then it will be able to classify and predict your data. I'm stopping here. The UI, because this will keep on running. Okay. Right. The next is how do you get data? There are different sources to data. You can go around, you can find your own data and you can work. Fine. It is up to you. Data could be sometimes not available. You have to go out of the way, find a source of data. You have to ask the people, can I get some data from your organization? With them also, you can try to get the data and you can proceed. Right. We have talked about statistical features. Architecture, choice of architecture is up to you. If you go to internet and ask, okay, I want to do object detection, they will say YOLO is the best architecture to do YOLO object detection, right? So you can try that also. In the process with my students, Mukesh and Rahul, we have made one tool called as metadata tool. And this tool is basically an analytics tool. What it will do is it will give you an analysis if you give a data. If you give a data in CSV file, like what I was showing you, it will give you a complete analysis. What happens if it is to be a machine learning? What happens if it is to be a result from a deep learning? Prototype part is little ready, so we will put it for an academic purpose shortly on the internet. Please feel free to give back your feedback and comments on this. Now, next what I want people to start learning or understanding with me is like, okay, how does a k-means work? Okay, because this is very important for people to know. Then we'll come to the deep learning part and outputs. Now, if you have some data like this, just see your data, right? If I have some data here like this, what I want to do is like I have a data. Right, let me remove all this so that now what I do is like I need to have some measure to form clusters. So my measure is average, right? So I brought some rules here. It's up to you. You can always say there are only 2 clusters or 3 clusters like this. So I'm just saying 32 to 36 is cluster 1, 37 to 39 is cluster 2, 39 to 41 is cluster 3, and 42 to 59 is cluster 4. Now what I do here is I start finding the average, right? So it's common example. So let's take, we do the average with respect to these features. Fine. So like this, I can form average for all the individual data. Now what we are doing is an unsupervised learning for all your information. Okay, right. Now I can go to the cluster range. 32 to 36 is cluster 1. Now looking at 45, it comes into cluster 4. So my class label is 4. 32 is 1, right? 39.5 will come into 3. 37.5 will come into 2. 35.5 will come into 1. Now my classification is ready. Now somebody will start argumenting or generally asking, why did you go for 4? It can be 3 or 2 like that. Common thing, based on the domain of the problem, you can fix your measure to classify into clusters. Or you can always go for techniques on the internet for classification, right? That techniques is up to you. I'll show you one technique for your reference. If you go to the internet and type elbow method for k-means, right? You will get a lot of techniques for fixing the cluster, right? You can use any one of the technique for finding your cluster value, which is k, right? Or based on the domain of the problem, you can formulate your clusters and you can say my cluster level is fixed. Once you're done with it, then the next question somebody would ask is, okay, what do you do in your testing? So this is my test data, right? When I give this test data, here what I am supposed to do, I am supposed to use an algorithm from supervised. So I might use KNN. Using KNN, this is my training data, right? So with my training data, I know the class label values are available. So whatever class I get here will be out of this class either 1 to 4 based on the training data, right? So I run a KNN using the distance measure concept. It will automatically say whether it is class 1 or class 2 or class 3 or class 4. This is how generally algorithms work in machine learning. Okay. Now, why I'm saying this to all of you is, if somebody says I'm using deep learning, right, then people will generally ask a doubt. What is this difference that you're saying expected, actual, expected, actual? How do you say that's an expected, that's an actual, right? So it's like this. When you look at this one, right? So I run through a k-means, I got this values. Fine. Okay. Now I'm giving a test data. This is my test data. Please see here. This is my test data. Now I want to run through a deep learning approach. Now, with my deep learning approach, when I'm running, I will get a specific class label. Okay. So let's take the class label. It is saying is 1, for example, right? The class label it is saying is 1, for example. Now there's a probability score to say how much this says it as 1, right? So you can find the difference between the actual and the expected. Expected one was 1 if you're going for k-means. Actual value that you got is 1. But don't talk as class labels. If you talk as class labels, it is 1 minus 1 is 0, right? I'm talking about the probability score value. So when you find the difference, you will get a error value. That error value is what you are seeing here in all your outputs, right, as error. This error will be expressed as a loss, right? When the loss becomes minimal, automatically the model will stop. Okay, this is the next information to all of you. So this is how a error component is calculated when you come to the case of deep learning. Last one, which I want people to understand is when you come to deep learning, there are different ways of looking at deep learning. People talk about models being created and so on. Let's take a small example here. If you look at this example, one second. Yeah, right. Just see here. Here, first thing people are talking about is the architecture of the model that is being used. Here they are using a Cont, right? Now come to the layers. Convolution layer, then they are using activation function, then they are using a pooling layer, then they are using a convolution layer, follow on an activation function, pooling layer, fully connected layer, softmax layer. Somebody can actually go and modify this. You can actually go here and say, I'm using one more convolution layer. When you use one more convolution layer, what will happen in the model? Your model will go like this. Just see here, like this. I think people can understand. Right? So I'm using one more convolution layer. That means it will have a combination with an activation function with a pooling layer. You can increase the number of hidden layers. This is what I'm saying again and again. When you increase the number of hidden layers, the learning capability of the model automatically increases. Okay. Now let's see through an implementation part for this. This is the implementation part for this. So whenever you have code in deep learning, you will see packages relevant to what is being used. For example, Keras is used, you will find a keyword called as Keras. Here we are importing a model of type sequential model. Then as I told you, under the layers, we can have activation, we will have a convolution 2D followed by that a dense operation, right? Now, if you come down to the code, we are taking data which is already there. This data as such is what we are talking about is from here. So let me show you the data, right? Okay. Now every data is an image, but below that, if you can find a text file that will show you the class label. This is class 1. This is of class 1. Okay. Now let's take this image 10. This is also of class 1. So every image will have an equivalent class label, right? Why? In the sense, people should understand that I already told you, whenever we are going for deep learning, right, we will try to compare the results with the original classified label. Right? So every training data should have a class label. So you cannot have just an image. If it is trained already, you will have a class label for it. Right? Now what we are doing is, we are trying to train the model using this. So we go here, we try running the model. Now what it will do is, it will take an entire set of records. Records here in the sense images. There is 1210 images. There's totally 70% being taken for training, for example. So it takes 303, right? So it is actually splitting the training data and testing data like this. 70% is 1210 and 30% of the entire images is 303, right? Then once it runs through the model, now what it is doing is, it is running. It is running in the sense, please try to understand, it is doing this operation. It takes all the images, right, with whatever parameters we have specified in the architecture. Finally, what it does is, it shows the accuracy score with which it has now classified the data. Is it okay? This is how a general training process for deep learning happens. Then next, what I want you to see is some applications that we are working now. One application that we are working now is like, we are trying to work with a data from a fish tank. Fish tank. Okay. So if you have video from a fish tank, what you will be interested to know from the video? Any guess? Can anybody say? Participants, organizers, anybody? If I have video from a fish tank, what you will be interested to see from the video? It's a big silence. Type of fish, okay, fine. Then anybody else? You can type in the chat box also. number of fishes, color of fishes, okay, count of each type of fish, various sizes, okay. Fine. There's some answers, responses coming in. Fine. So I'll show you the results. With that, I think you will understand what we are trying to do. Once again, I'll share the video. Features of each type of fish, variety of fishes, behavior of swimming. Oh, good. Good thinking. Once again, I'll just running the video. I'm sharing the screen. Yes. I think people should be able to see my screen. Now let me show you some results. Now, I think you are able to see, members, a video player started.
Yes, sir.
Yeah.
We are able to see, sir.
Yeah, so this is the results that we have got. This is from a fish tank. You can see fishes moving. So what we are doing is tracking of the fishes, as you all said. We want to see big fish, small fish, right? All that. Here we are using an algorithm called as optical flow based tracking. Why are we doing this? This is one work that we are doing with a professor in abroad. The requirement is like this. The professor has a big fish tank at home, right, after retirement. So he has got camera. It's an IoT based model, all that. What he wants is like he wants to find out the big fishes and small fishes. Reason is whenever food is put up, big fishes come to the top and take the food and go down. But small fishes finally do not have the food. So he just want to know at a particular place at the top of the water how many big fishes have come, how many small fishes have come and taken the food. So based on it, he want to adjust the amount of food that he want to put around the fish tank so that all fishes are not hungry, right? This is one problem that we are working. This is our preliminary results from our team. This is again a video analytics based problem because here we are using optical flow based algorithm. We are doing some analytics. What is analytics is like when will the fish be hungry whenever it comes to the top and waits for a food. Somebody might ask like, is all the fishes hungry? You would say yes, all the fishes have come up, so everybody is hungry also, right? So there's a bit of analytics here. The next one that I want you to see is about fault detection. This is one problem that we are working. Here, as such, this is a very common problem now. People are having a lot of people at aged homes at home. Yeah, let's say camera is there and somebody is trying to come inside, right? And they suddenly fall down. You have to watch the activity. This is an activity-based recognition problem, right? And let's take the person falls down by mistake, right? And let's take he or she is not well and tries to fall down. So it will start saying that it's a fall. You can see on the caption on the top, right? It has detected it as a fall. Now you can actually go around and wait for a couple of frames. If the person is very unconscious, you can try to inform to the health department or that's your hospital, or you can try to inform the relation that the person is not well, like that, right? It again depends how much time you want to wait, right? But our concern is about the next activity when the person tries to get back, right? The person is okay and gets back. So what will happen to the activity? Assume the person is trying to get back, right? Once a person gets back, then automatically it will say that it is not a fall, and it will classify the activity also, right? This is one problem that we are working this year with our students. You can see here the person is getting up, so it is originally showing an activity of fall, it will change to not fall, right? Okay, so this is for many different reasons. Somebody is not well, falls down, or somebody is having a health condition difficult, or somebody is having any disease because of which the person falls down. So many cases can be addressed under this problem, right? I just want you to see this so that you get a feel of what we are trying to do. Then going forward, there are many places where you can do fall detection. As I told you, like you can use it in homes, you can use it in retirement homes, right? Because there are a lot of people now staying in retirement homes. Suddenly they fall down, can it inform the security? Many problems are still open for people. Face detection, somebody is lying on the road, but it's a dark time, person is unconscious, can it pick up the face and send a message to the police station? Because we see a lot of missing cases, at least on TVs we can see, right? Okay, so can it say this person is found on the road, right? Lying, sleeping, whatever you can assume. Second is malpractice detection. Now that's becoming a need, like somebody is taking exam, is he copying, is he looking front, back, whatever it is, can it be taken up? Healthcare is a problem now. Given COVID data, can you develop a deep learning model for healthcare? Network intrusion detection. This is one project that I'm working with my team in Amrita. It's a funded project from IBM. So what we do here is like if packets are going around the network, can you actually find the malware in the packets, and you can say that your network is in trouble, right? It's a very challenging problem. There's a lot of scope for people to work, and malwares now has become very intelligent. You would have heard that people are trying to connect to your computer and they are trying to steal your data. Data they are trying to steal is not data now, it is actually your computer resource. So you have a powerful computer with powerful RAM, but your system is slow. It may be because a malware has come to your computer and the hacker is accessing your computer from the remote. That means the hacker can run his applications on your computer, but you will not know that, right? That's a new type of malware attacks that are come now. Agriculture, what we see is a real application is like, let's take there's an agricultural land and there's a lot of insects that has come. Can you find out how many insects have come, and can you regulate the amount of medicine sprays that could be coming up? Because all times you cannot stand in the field and find out the insects, right? They come in the night and destroy the field. Can you find it out? Right, that's a big question. Then last one is call taxi booking. This I usually talk to people about this application because the clients usually have a requirement. If you develop a call taxi software, your answer is like if somebody is asking a call taxi, the taxi which is closer to you will be booked. But it's not like that always. The taxi providers will have many other conditions. The taxi provider might say between the two taxis, one person has got more trips, one person has got less trips. So the person has got less trips, even if it is far away from you, will get the booking because he is happy that he has got one more trip, right? So there are other factors to the data which also participates to the deep learning models. That's why I take this example and say to everybody. Going along, there are a lot of data sets on the internet which you can go through. I showed you some data sets also. What I would like to conclude is like I have taken you through the journey of deep learning, and I have said you what deep learning is, how does deep learning work, what is the deep learning architecture in general, and going forward, your application will ask you many questions. Okay, this is my data. How do I work with my data? There you will have to make quick design decisions about why you're going for deep learning. If your problem doesn't use deep learning, please do not go for deep learning at all. For example, insurance problems, if you take no, deep learning is not a good solution. Because today, even if you go to companies, the companies will say that we are happy with the decision trees. Decision trees are the best case for me to solve insurance applications. They don't want deep learning and all, right? So if your problem really demands deep learning, please come to deep learning. So that's all from my side. Thank you to the organizers. Thank you to Usha ma'am, and credits always to my students, and thanks to my PhD guide. My PhD guide was S.N. Shivanandam sir, formerly Professor Computer Science in PhD Tech, and he's my guide. He only got me into the field of machine learning and video processing. Then I've been trying to grow, and today what I am is because of my PhD guide also, Dr. S. Shivanandam sir. Thanks to him, and thanks to the organizers. Thanks to Usha ma'am. If there's any questions, I will take it up. If there's anything forward, I've sent my email ID also in the chat message. Please write me a mail and clarify also.
I request participants to post the queries in the chat box. Participants, if you have any queries, please post them in the chat box. There are no questions in the chat box. Okay, there is one.
Yeah, which models of deep learning are used for image enhancement? So if you look at deep learning models, most of the deep learning models can be used. Even CNN is the best technique for image enhancement. But generally, if you work with image enhancement, you will have only less examples for training. So there, people suggest to go for transfer learning. So you can use transfer learning based models for image enhancement. I think I've answered you, sir. Chandramouli, sir. Thank you, sir.
If there are any more questions, participants, please post them in the chat box. There are no questions. So we are assuming there are no questions because there are no questions in the chat box. Thank you, sir, for an insightful session on deep learning. It was indeed an honor for us to have a resource person for today's session.